Hello viewer, today we're gonna look at how to conduct multiple linear regression as well as relative weights analysis in RStudio. As you can see here, I have a data set pulled up in the RStudio environment. You've got here 4 continuous variables listed with the number indication by RStudio. You've got outcome, which is going to be our outcome variable, pretty fitting, and 3 other variables, which might as well just say predictor 1, predictor 2, and predictor 3. That's my dog Scout barking. She's very cute. And then the final variable we have here is our grouping variable, aptly named group. And you see it just kind of says a bunch of 1s, but there are a few 2s in there as well. So yeah, we're going to do a multiple linear regression using these 3, MTL, SD, and SE, as predictors of our outcome variable outcome. So a little bit about why we do relative weights analysis. Presumably, we would expect that 1 or 2 of these 3 predictor variables would be correlated with each other before we'd want to do relative weights analysis, because that correlation, what that would do to a standardized beta weight, it would influence it basically and make it not a super accurate representation of what that predictor contributes to the overall outcome. So a relative weights analysis could be done to make an orthogonal transformation so that a new variable is created that's not correlated with the original. Unfortunately, this data set doesn't have correlated predictors, so the whole point of RWA is a little bit lost, but we can still get some insights by looking through this data. So let's go ahead and get to it. I'm going to go ahead and clear my environment so that you can kind of see what's going on as I run through this code in my thing. Cool. Yes, please get rid of everything. Thank you. All right. First, we're going to run these little bits that open the library so that I can use this function read Excel, and then later this function boot, which it's kind of weird that this is in here because you're going to see that later when you copy your RWA syntax from the website that we're going to use to get that data. But I went ahead and put it up here because I didn't want to keep putting the library boot in, because as you're going to see, you're going to want to run that more than once. But anyway, don't need to know about that now, but I just have it here up at the top. Yeah, let's go ahead and run those. Boom. Alright, now we have the libraries we need. You can see it pop up in the console. And go ahead and load in our data set as well. And look, hey, it's back. Cool. Same exact data set, but just showing you that is how you upload it. So this is our syntax for our multiple linear regression. So I'm going to have LM, that's a linear model of outcome, regressed onto our 3 predictors. I'm going to push that into MLR model, so that's just a variable name for that. Now let's go ahead and run that. You'll see our MLR model pops up in our environment. And to go ahead and get that to pop up in the console, I'm going to run these 2 lines. Alright, now we've got some new stuff in our console. You can see we've got the information from the linear model up here. We've got our intercept and our three predictor variables here. We've got our overall significance down here. So you can see our model is significant, which is cool, but none of our predictors are significant based on these p-values right here, these three. Our intercept is significant, so basically we've got kind of the worst case scenario of what we would expect of multiple linear regression, or what we would, I guess, want to see. Don't want to see that, but it's what we got, so it's what we're going to work with, and we're gonna see what that means for our relative weights analysis when we finally get to that. But before we get to that, we're not really done with multiple linear regression, because this is just a regular linear regression, and these values, these estimates, are not standardized, so they're not beta weights, they're just p weights. So in order to standardize them and get betas that we can compare our RWAs to, we're going to have to standardize all of our continuous variables. So you can see this line here. Oh, well, you know, maybe our outcome already is standardized. Let's go ahead and check to see if it is standardized by running some means analysis and some standard deviations on the outcome variable, which is what these two lines do here. Boom. Spoiler alert, they are not standard enough. We would want this to be closer to 0 than it is, and this should be exactly 1. Luckily, R has got our back, and we can standardize outcome. So I've got this line here called Z outcome. We're going to push scale outcome into Z outcome and create a new standardized outcome variable. Go ahead and run that. Boom. Got a new thing, Z outcome over here. And let's see if that's actually standardized by running the mean and standard deviation for Z outcome. Boom, boom. Yeah, that's pretty close to 0, I would say. E negative 19, a lot closer than this number is. And then exactly 1, so that's exactly what we want to see. Of course, we have to standardize our predictors as well. So that's what I did in this line here. You don't actually have to take the variables and create new standardized variables for your environment. You can just go ahead and put the scale function inside of the formula. So that's what I did here, and I created this new model, the standardized model. But when I calculated the regression, I just used the standardized outcome variable that I already made, but I didn't make new variables for these. I just scaled them for this function alone, because we're not really going to need them ever again. Let's go ahead and run this line. And then run some lines to actually show the model. Now it's in our environment and in our console. So yeah, what you can see here is similar type of chart here, except we've got standardized estimates now. Model is still significant, but none of our predictors are significant still. You wouldn't expect that to change, so that's a good thing. Standard errors, of course, are going to change. Your t-values should not have changed, though, so let's go back and check. Make sure that those t-values are aligned with what we had previously. Yeah, looks like we're good. Cool, so now that we've got these standardized beta weights, which are these estimates right here. If we assumed that these variables were correlated, any of these two were correlated with each other, we would want to not really use these betas and instead look at a RWA output, because those would be more accurate in terms of showing which predictors have the greater effect on the outcome given that our regression would actually be significant, which it's not, but okay. Yeah, anyway, RWAs, we're going to go to this website that's going to pop out some R code for us. We're done coding for the moment. And actually, if you've been paying some attention to my window up here, after this first comment, start first RWA syntax is all stuff that I just copied from the website. So that's the last line that I wrote that we're actually going to run today. But cool. We're going to go over to your favorite web browser and type in relativeimportance.davidson.edu/multiple-regression.html, and you're going to see this nice, lovely page of lots of text that you don't need to read because I am here to tell you what it says. So starting right here at this choose, this is going to be where you put in the location of your data file. In this box here, and you're going to want to make sure you put in your exact path for the data file. If you're on a Windows machine, it's going to look something like this example here. If you're on a Mac, I'm not sure exactly what it's going to look like, but it might look a little bit different. Notably, I don't think you're going to see this like C symbol, but you do need to make sure that you have your, oh hey look, Steven's email address shows up in this box. That's kind of weird. Oh god. Ignore that. You're going to want to put your exact path here, and if you're not sure how to get your path, you can actually get that in R by importing a data set from Excel, let's say, because it's an XLS that I'm using, and then find the data set that you want. Click on it. Open, and you don't actually have to upload it into R, but if you see right up here, this is your path. You can just go ahead and copy it from there. And paste. Cool. So we are done with this section, this little box. You could send it to the R server, which is neat, and also have it emailed to you, I guess, if you wanted to. I haven't messed around with any of that, but cool options if that's what you want to do. Is the data a correlation matrix or raw data? We are working with raw data, so I'm going to select that and use listwise deletion or pairwise deletion. Doesn't particularly matter, up to your discretion. I'm going to go ahead and choose listwise deletion. Alright, cool. Here in this box, we're going to name our criterion variable, which if you remember earlier, we identified as outcome. Make sure you have all of your capitalizations in order. And then our predictor variables, which, as I mentioned earlier, might as well have been predictor 1, 2, and 3, but aren't actually. So let me go back and check. Okay, we got MTL, SD, and SE. So I'm going to go ahead and MTL, and then separated by a return, SD, and SE. Cool, now we have our predictor variables for it. Number of bootstrapping replications, 10,000 is pretty much what you want. Wouldn't recommend changing that. Though I guess you could if you wanted to play with it, but 10,000 recommended number. Alpha value, again, it's pretty standard, 0.05. Probably wouldn't change it, but if you want to play around with it, you can. And that's what's going to give you just your regular old relative weights analysis. If you didn't want to test anything else, then you could pop that out and have some relative weights to work with. But we've got some kind of extra options for the bootstrapping. We can test if the relative weights are significantly different from each other. So basically comparing MTL to SD and SE, and you can actually only do comparisons to one variable at a time. So in order to look at all of the pairs between these three variables, you have to run this twice, which is kind of what I was alluding to earlier. Not a super big deal, but we're going to go ahead and put MTL in here. So what this round is going to do is it's going to compare MTL to SD and SE, and then to get that